Welcome back to the workshop. We want to take a look at the second section of the appendix, which is talking about logical equivalence. So we're not quite to logical equivalence yet. We want a little bit more exposure with our truth tables, so that way we can easily identify logical equivalence. So we'll take a look at two more examples in this video. So this is maybe not quite as large of a truth table that will be required as our last example in the previous video, but it's still, again, trying to emphasize the idea of combining only two columns to create a new column at a time. So we start with P and Q themselves because those are the only two component statements. Now we haven't assigned or said what P and Q are, and that's not what we're concerned with for these truth tables. P and Q can be any statement. We're generalizing these, okay? And we're just looking at the possible combinations of truth values for P and Q, right? Once you have an actual statement, then you actually know whether it is true or false. And you wouldn't be looking at a table, you'd just be looking at one row. This is true, that's false, so the conjunction is false, or the disjunction is true, or the implication is false, or maybe true, depending on which way it went. Okay. Anyway, so we're not looking at specific statements, we're looking at the general statements P and Q. So what are the possible truth values for P and Q? Well, we could have true, true, false, false, because it's still the same two statements that we've been looking at, okay, or the idea that there's two of them. So then the next thing that we want to do is what? Well, we want to find the conjunction of P and not Q. So I have two things. I have P and not Q that I want to find the conjunction of. So the first thing I need to do is find not Q, and then I can find the conjunction. So I need not Q. Now, not Q just negates Q. So we're saying that, right, we're exchanging truth values. So where it's true, it becomes false, false, it becomes true, and that's it. Easy enough. Now I can find the conjunction of P and not Q. So I'm looking for when they're both true. True and false, it's false. True and true, it's true. False and false, it's false. False and true, it's false. Simple enough. All right, so let's take a look at something that's a little bit more interesting. There's still maybe not a lot going on here. However, there are more statements now. P, Q, and R. So I need P, Q, and R. Now, how many possible combinations of truth values are there for three statements? Well, if you haven't figured it out yet, what we're talking about is there's two options for this one, two options for that one, two options for this one. And according to the multiplication principle for counting, we would say 2 times 2 times 2 is 8. So there are 8 possible combinations. So what it works out to be is that I can say true, 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 false, 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 right? 8 truth values, 4 true, 4 false. And now I do true, true, false, false, true, true, false, false. And then finally, true, false, true, false. True, false, true, false. True, false, true, false. Excellent. So I have my component statements figured out. Now I want to construct my compound statement. So what I've got is I've got this thing and that thing. So I need to figure out this thing before I can perform that conjunction. All right. So for this, I have P or not Q. Okay, so before I can do the disjunction, I need to find not Q. All right, so not Q. Once I find that, I can find the disjunction. Once I have the disjunction, then I can find the conjunction. All right, so let's get rid of that a moment. Not Q. Well, that would be false. True becomes false. True becomes false. False becomes true. False becomes true, and so on. Excellent. So I've got this guy. Now I can find the, right. So this was the first thing I did. I found the individuals, and then I found the negation. Now I can find the disjunction, P or not Q, P or not Q. So P is true, not Q is false. I just need one of them to be true for P or not Q to be true. One of them is true. In fact, one of them is true for the first 4, certainly, because P is true. Now, once we get over here, this is false, so I just got to check these guys, not Q. So I've got false, false, true, true, because I need at least one of them to be true. False, false means false, false, false means false. One true gives it true. All right, so now I've got that. So now I can find the conjunction of P or not Q and, right, this is the conjunction, and R. So this and that. True and true, so it's true. False. One of them is false, so it must be false. True and true. False. True and false. False and false. True and true. False and true. So there we go. Those are the truth values for this compound statement. Simple as that. All right. That's all that I wanted to share for this video. So of course, I've got more examples, and in the next example, we'll actually have a couple definitions and an example of a truth table to follow each definition. So I'll see you guys back in the workshop very shortly.